Hi everyone, welcome back to chemistry. In this video, we're going to do a quick review of scientific notation. So a lot of times in science, scientists need to express very large or very small numbers. And scientific notation is a way that we can express those really large or small numbers in a more concise way. So let's kind of put this in practice just to start with. So anytime you're looking at a number in scientific notation, you're going to have these different parts to that number. So there's always some coefficient, and we're calling that coefficient m here, but it's just going to be a number, some number. Okay, and that number actually must be between 1 and 10. So what do I mean by that? I mean that you can have some kind of number there instead of m that's, between 1 and 10, something like 1.5 or 2 or 3.5. What you can't have is something like 0.5. And why can't you have 0.5? Well, that's because 0.5 is less than 1, right? And it has to be between 1 and 10. Likewise, you can't have a number 12 there. That's because it's more than 10. Okay, so that's just the rule, that's the convention. All right, so, and then there's this times 10 part where we're multiplying whatever coefficient, whatever number we have in front by 10 raised to some exponent. I guess we can use this glitter pen. 10 raised to some exponent. In this case, we're calling that exponent n, okay? And that exponent must be a whole number. Oh, let me switch back to let's do blue. Must be a whole number, and it can be positive or negative. Okay, so you can have a negative exponent, and what that means is that your number is smaller. Okay, it's a small number. If you have a positive exponent, you're going to have a larger number. All right, so let's check this out. For number 1, right now I'm noticing we have a decimal point already. Sometimes you'll have a question where it doesn't necessarily give you the decimal point, and in that case, you're going to put the decimal point at the end of the number because it's assumed that it's there, right? So there's an imaginary decimal point there. In this case, we do have it there, so that's great. So I'm going to highlight it just to kind of keep track of where it is, and then we're going to try to move that decimal point until it's we create a number that's between 1 and 10, right, for our coefficient. So let's go ahead and do that. So we're going to move this decimal point over 1, 2, 3, 4, 5. Am I going to stop there? No, I got to go one more, right? If I moved it just over here, I would have 12.5, and that's not a number between 1 and 0. So you want to move it between the first non-zero digit, okay, or right after the first non-zero digit. All right, so that gives me, and let's try this out, we got 1.25, just writing those numbers there, where I move that decimal point. And I'm noticing, okay, that coefficient is definitely a number between 1 and 10. And then we have to represent those zeros still, because this number and this one, these are not the same number, right? So you got to keep that times 10, okay? That's what's going to give us a number. Remember, our goal is to represent this exact number in a different way, okay? All right, so am I done? Can I just leave it like that? No, we got to tell how many spaces we moved that decimal point over, because that's going to give us our n, our exponent here. If I just left it like this, what would this number equal? Yeah, 12.5. 1.25 times 10 is 12.5. That's not the same thing as 1,250,000. So we got to put those decimal points in there. So we moved it over 1, 2, 3, 4, 5, 6 places. So it's going to be 1.25 times 10 to the 6th power. And you'll notice that we move that decimal point to the left. To the left. And that'll become important later just for a little trick that I'll show you. All right, in this next one, so now we've actually represented this number in scientific notation. Pretty cool. All right, so let's try the next one out. So now notice that I've got a decimal point right here. What does this, is this number a big number or a small number? Yeah, it's a really small number, right? We've got a lot of zeros before our first non-zero digit, 0.0000233. So I'm expecting this exponent, the exponent that I'm going to write, are we going to expect it to be positive or negative? Yeah, negative, because it's a really small number. Okay, so we want to move this decimal point again until we have it between the first two non-zero digits. That's going to give us a number between 1 and 10. Okay, so I'm moving it between the 2 and the 3 there. So I'm going to write 2.33 times, I know I'm going to have times 10 to the something, right? But 10 to the what? So I moved my decimal point over 1, 2, 3, 4, and 5 spaces. So if I write it like this, is that correct? No, that's not correct. These are not the same numbers right now. And that's because when I multiply 2.33 times 10 to the 5th power, I'm going to expect a very large number, right? 10 to the 5th is a large number. So I'm not going to write that. Instead, I'm going to put a little negative sign there. And the reason for that is that this is a small number. Okay. Another reason for that is that I moved, oh, and I erased it, sorry. I moved my decimal point over to the right. Anytime, and here's the trick here, anytime you're moving your decimal point over to the right, you've got a small number. A small number means that you're going to have that negative in front of your exponent. Okay, and anytime you move your decimal point over to the left, it's going to be the opposite, right? You're going to have a positive exponent because that's a large number. Okay, so that's some kind of trick you can use if it helps. If it doesn't help, don't think of it that way, right? Just think of it as small number or big number. All right, let's try a couple more. So express 240,000 in scientific notation. So again, I've got my decimal point there. If you didn't see it there, you can put an imaginary one at the end of the number. But here we've got it. So we need to move that decimal point until we have a coefficient that is between 1 and 10. So I'm going to move this over 1 and 2 and 3 and 4 and 5. So I'm going to write 2.4 times 10 to the what? Yes, 5, positive 5, right? Big number. And now I've represented this number in scientific notation. Same number, right? These are expressing the same exact number. In fact, plug this into your calculator and see if you get this number, and you will. Okay, as long as you did it right. If you don't get the same number, that's a really good check, and you can reevaluate check your answer. All right, so express 0.0035 in scientific notation. So again, we're going to kind of look for our decimal point. We're going to move that decimal point over until we get a number between 1 and 10. So we have 3.5 times 10 to the something, 10 to the what? Well, we moved it over to the right 3 times, so we're going to have a negative 3 exponent. You could also think of it as this is a number that's less than 1, so we're going to have a negative exponent. You could also think of it as a small number, right? Negative exponent. Okay? Whatever way it helps it's for you to think about it that way. All right, now sometimes we're going to switch from scientific notation into what's called standard notation. And this is just the regular way that you are used to seeing numbers. Okay? So this would be this would be a number in standard notation, as with this, right? So this time we're given a number in scientific notation and we want to convert back to standard notation. So the way this works, and what I like to do, is I like to write my coefficient. So I'm just kind of copying that coefficient down here. And then I'm going to move the decimal point over whichever way I need to in order to correctly represent whether that number is big or small. Okay, so what do I mean by that? All right, and here's the tricky part. So when we're expressing a number in scientific notation, I gave you a couple shortcuts. Those shortcuts do not work in this case. Okay, they only work when you're converting a number into scientific notation. When you're trying to convert back to standard notation, I recommend that you think about it in terms of whether the number is big or small. So this is a what? Big number or small number? Yes, a small number, right? 10 to the negative 6. Okay, so I would expect my number to be small. And the only way I'm going to get a small number out of this is to move that decimal point to the left. Okay, so I'm going to move that to the left. We'll go blue here. So 1, 2, 3, 4, 5, and 6 spaces to the left. Okay, and then I have to populate those spaces with our zeros. So 0 here, 0 here, 0 here, here, and here. There's my decimal point, and I've got a 0 in front. All right, so let's clean this up. And we've got 0.000. Oh, how many? 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. 3, 4. All right, now let's try the next one. So we got 7.91 times 10 to the 4th, and we want to convert that to standard notation. So I'm again going to just write down my coefficient there so that I can kind of move that decimal place around. And now think about this. Is this number big or small? It's a big number, right? So would we expect a bunch of zeros in front of our coefficient or a bunch of zeros after our coefficient? Yeah, a bunch of zeros after, right? That's going to give us a big number. If I put them in front, I'm going to have a small number like this. And that's not going to represent our large number here. So let's go ahead and move that decimal point over to the right this time. So 1, 2, 3, 4, 4 times. And let's populate those zeros in there. So we got 0, 0. All right, so I got 79100. That is this number in standard notation.